Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to solve systems of nonlinear equations using the elimination method. In this first one we've got 16x squared plus 25y squared equals 400 and x squared plus y squared equals 16. Now notice both equations just have x squared and y squared terms on the left-hand side equal to some constant on the right. We can use elimination just like we did when we were working with only x and y instead of x squared and y squared. Here, we can eliminate the variable x squared by multiplying the second equation by negative 16. So I'm just going to copy over the first one. 16x squared plus 25y squared equals 400. And the second, I'm going to multiply by negative 16. So that's negative 16x squared minus 16y squared equals, and then negative 16 times 16 is negative 256. When I add the equations together, the variable x squared is eliminated, leaving 9y squared equals 144. Divide through by 9, and we get y squared equals 16. Take the square root of both sides, including plus or minus the square root for the 16, and we get y equals plus or minus 4. Now to find x, we can go to either of the original equations. Let's try the second one that seems simpler. X squared plus y squared equals 16. If we put in 4 for y, x squared plus 4 squared equals 16. We get x squared plus 16 equals 16. X squared equals 0. X equals 0. So one of our solutions is 0, 4. If we use negative 4, everything we just did would be exactly the same because negative 4 squared is also 16. Let me just show you really quickly. X squared plus negative 4 squared equals 16. X squared plus 16 equals 16. X equals 0. So the two solutions are 0 for x with 4 for y and 0 for x with negative 4 for y. We do need to, we should check it in the other equation. Let's go ahead and take a look at that. We're going to check using 16x squared plus 25y squared equals 400. And when we do that, we'll start with the 0, 4. 16 times 0 squared plus 25 times 4 squared. Does that equal 400? Well, the first term is just 0 because 0 squared is 0. But we get 25 times 16, and that does equal 400. So 0, 4 is a solution, and 0, negative 4 will give us the same exact thing. So both of these solutions are okay. Let's try one more for the elimination method. Okay, moving on to example 4. We've got 9x squared plus 4y squared equals 87. And x squared minus 2y squared equals 6. When we have x squared and y squared together on the left side of the equation with no other variable terms, elimination is usually the best way to go. Here we can eliminate the variable y by multiplying the bottom equation by 2. That'll give us 2x squared minus 4y squared equals 12. And if I copy over the other equation, 9x squared plus 4y squared equals 87, the two terms containing y squared are opposites and will add to be 0. When we add the two equations together, we get 11x squared equals 99. Divide by 11, and we get x squared equals 9. Take the square root of both sides. That is equal to plus or minus the square root of 9, and x equals plus or minus 3. So now, we're going to go back and use the top equation to try to find the y value that goes with them. We're back. If we put in 3 there, that's 9 times 3 squared plus 4y squared equals 87. 3 squared is 9, times 9 is 81. So we can subtract 81 from both sides of the equation. We get 4y squared equals 6. Divide over the 4, y squared equals 6/4, or 3/2, and y would equal plus or minus the square root of 3/2. But we don't like to leave the denominator inside the fraction like that. So actually, if we go back to that 6/4 and we take the square root of 6 and 4, we get plus or minus the square root of 6 over 2. And then we can approximate that in the calculator if we want to. If we use -3 for x, we get the same pair of solutions. So the 4 solutions, when x is 3, we have 3 and plus or minus root 6 all over 2. And 3, just a positive root 6 over 2. And then 3 negative root 6 over 2. And then we get the same thing beginning with -3, root 6 over 2, and -3 negative root 6 over 2. So 4 potential solutions. The good part about checking these is that when we square each term, whether it's positive or negative, the squared result will be positive. And so we really only need to check one of these. The other 3 will go along for the ride with it. So using the second equation, x squared minus 2y squared equals 6. Put in 3 for x, minus 2 times root 6 over 2 squared. Does that equal 6? We get 9, minus 2 times 6 over 4. Does that equal 6? 2 times 6 over 4 is actually 12 over 4, or 3. So we get 9 minus 3, and that does equal 6. So all 4 of these solutions would check the same exact way, and we have 4 solutions to this system.